4 billion miles from where you're sitting right now, a dwarf planet is quietly operating its own private cooling system, chilling itself down using nothing more than the haze hanging in its own sky. Nobody expected a world this small and this cold to be capable of anything like that. Stick with me, because I'm about to walk you through exactly what scientists have just confirmed about Pluto. And go ahead and subscribe now, because this channel digs into real space discoveries without piling on the hype, and you don't want to miss what's coming next out of the outer solar system. Let's rewind to where this whole story actually starts, because Pluto's backstory is far stranger than most people remember. Back in 1930, a 24-year-old observatory assistant named Clyde Tombaugh, working just outside Flagstaff, Arizona, was handed one of the most mind-numbing jobs imaginable. Night after night, he photographed the same patch of sky, then flipped rapidly between plates, searching for a single point of light that had nudged out of place. Most nights turned up absolutely nothing. Then, on one plate in February of that year, something shifted. A tiny speck had moved against the backdrop of fixed stars, and that speck turned out to be Pluto. For most of the following century, it carried the title of the 9th planet in our solar system, even though it sat so far away and appeared so small that astronomers could only speculate about what it truly looked like up close. Then, in 2006, the International Astronomical Union held a vote and formally reclassified Pluto as a dwarf planet, stripping away the label that had made it famous. To this day, it remains the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the very category that had once defined it. For a while, that felt like the closing chapter. Pluto seemed small, remote, and easy to shelve as unimportant. That assumption didn't survive its first real encounter with data. It's worth dwelling on just how little we genuinely knew about Pluto before any spacecraft ever got near it. For most of the 20th century, even Earth's largest telescopes could only resolve it as a faint, blurry smear of light. Astronomers could pin down its orbit with reasonable precision, since that only required tracking its position over time. But its actual size, its surface makeup, and even whether it had any atmosphere at all, remained genuinely unanswered questions for decades. Some early estimates wildly inflated its size, based on the assumption that it needed to be massive enough to explain certain gravitational quirks in the orbits of Neptune and Uranus, quirks that later turned out to be measurement errors rather than anything Pluto was actually causing. In other words, a lot of what the public believed about Pluto for generations was guesswork built on top of more guesswork, which makes what happened next all the more striking. In July 2015, after a 9.5-year trek across billions of miles of empty space, NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles per hour. It got exactly one shot, no orbit, no second pass, just a narrow window of a few minutes to gather everything it could before hurtling onward into the darkness of the Kuiper Belt, never to return. What it beamed back completely upended what scientists thought they knew. A massive, pale, heart-shaped plane stretched across the surface, smooth and oddly youthful-looking, compared to the ancient, heavily cratered ground surrounding it. Mountains built from solid water ice rose over 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like bedrock. Fields of nitrogen ice appeared to churn slowly in vast convection patterns, hinting at heat and motion happening beneath a crust everyone had assumed was completely inert. And layer upon layer of blue haze rose hundreds of miles above the surface, visible even when backlit by sunlight. Pluto didn't look like a discarded chunk of frozen rock. It looked like a world still actively becoming something. But New Horizons only got that one glimpse. It captured what it captured and kept flying deeper into the outer solar system, never coming back. Whatever it missed on that single pass would stay a mystery for years. While scientists argued over the data and built models they had no practical way to test, what researchers really needed wasn't a sharper photograph. They needed a way to read Pluto's chemistry directly from millions of miles away without launching another spacecraft. That is precisely what the James Webb Space Telescope eventually made possible. Here's what sets Webb fundamentally apart from a spacecraft like New Horizons. Webb doesn't zoom past anything and snap a picture. Instead, it reads light itself, splitting it into its individual wavelengths to reveal the precise chemical signature of whatever it's observing. Aimed at a faint pinprick of reflected sunlight billions of miles away, it can tell researchers which molecules are present, how warm different layers of an atmosphere really are, and how that atmosphere behaves over time, all without physically traveling anywhere. The technical hurdle here deserves its own appreciation. Pluto and its moon Charon sit so close together in Webb's field of view that separating their individual heat signatures used to be nearly impossible with earlier telescope generations. Researchers working before Webb launched had repeatedly tried to detect this exact haze signature, and repeatedly come up empty. Not because the signal wasn't real, but because their instruments simply couldn't distinguish how much of the detected heat was coming from Pluto itself versus bleeding in from Charon sitting right next door. Webb's much larger mirror and far more sensitive infrared instruments finally cracked that specific problem, letting scientists cleanly isolate Pluto's own thermal signature for the first time ever. Starting in 2022, once its instruments were fully calibrated and able to separate Pluto's faint signal from that of its outsized neighboring moon, Webb turned its gaze toward Pluto. What has come back in the years since hasn't simply been a prettier picture. It's amounted to something closer to a full diagnosis, revealing behaviors so unusual that researchers are still working out how to fully explain some of them. If you're the kind of viewer who wants space stories broken down clearly instead of buried in jargon, go ahead and drop a like right now. It genuinely helps this kind of content find more people who'd enjoy it. The first major finding centers on that same blue haze New Horizons first photographed back in 2015. Researchers already knew Pluto's thin atmosphere was wrapped in a delicate veil of hydrocarbon particles. What nobody had confirmed was exactly what that haze was actually doing to the world underneath it. Back in 2017, a planetary scientist named Shi Zhang at the University of California, Santa Cruz floated an idea that sounded almost backwards at the time. On Saturn's moon Titan, atmospheric haze traps heat and warms the surface below. Zhang argued that Pluto's haze might be doing precisely the opposite, soaking up sunlight during the day, and then radiating that energy straight back out into space as infrared heat, faster than Pluto's razor-thin atmosphere could ever hope to retain it. In effect, the haze wouldn't be behaving like a blanket. It would be behaving like a radiator, actively bleeding away heat from a world that had almost none to spare in the first place. At the time, plenty of Zhang's peers found the idea unlikely, and there simply wasn't an instrument sensitive enough yet to actually test it. That changed once Webb's mid-infrared instrument came online with enough sensitivity to cleanly separate Pluto's faint thermal signal from that of Charon, something earlier telescopes had never managed. A team led by astronomer Tanguy Bertrand at the Paris Observatory used that instrument to measure Pluto's atmosphere directly, and their results, published in the journal Nature Astronomy in June 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended within it, and it turns out to run roughly 30 degrees Fahrenheit colder than earlier models had predicted. Researchers now describe this as a genuinely new category of climate, one that behaves unlike any other atmosphere we've studied anywhere else in the solar system. Pluto isn't simply cold because it sits so far from the sun. In a very real sense, it appears to be actively refrigerating itself, and scientists are still mapping out how far the implications of that discovery extend, including whether similar hazes might be quietly shaping the climate of other distant, hazy worlds like Neptune's moon Triton, or even hinting at what Earth's own atmosphere might have looked like billions of years ago, long before oxygen ever accumulated in our skies. There's a second discovery tied to that same haze, and it's quieter, but honestly, just as strange once you sit with it. Even the faintest trickle of sunlight reaching Pluto is enough to split methane molecules apart high in its atmosphere. Those fragments don't just vanish, they recombine into heavier compounds, driving a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift downward and settle onto the surface. New Horizons caught early traces of this process back in 2015, and more recent observations have kept refining exactly how it unfolds. Here's the detail that tends to stop people cold. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially supplying raw material for the chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years, a slow, continuous snowfall of biological building blocks, landing on a surface far too frozen for any of it to ever spark into something alive. To really grasp how extreme that cold is, the raw numbers help. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth, meaning even high noon there would feel closer to a heavy twilight here. Surface temperatures generally hover somewhere between about -387 and -369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those temperatures, nitrogen, the same gas making up most of the air you're breathing right now, freezes completely solid. The very atmosphere surrounding you as you watch this would, on Pluto, simply become part of the frozen ground. It's worth explaining a bit more about why researchers care so much about this particular chemical process, beyond it simply being strange. Scientists studying the origins of life on Earth have long debated where the first organic building blocks actually came from, whether they formed here on the young planet itself, or whether at least some of that raw material arrived from space, delivered by comets, asteroids, or slow chemical processes unfolding in distant, icy environments, much like what we now see happening on Pluto. Studying a live, ongoing example of that chemistry, one that's been running continuously for billions of years on a nearby world, hands researchers something they otherwise could never get their hands on. An active natural laboratory for a process that, on Earth, wrapped up billions of years ago and left behind only indirect evidence. Pluto, in that sense, isn't just a curiosity. It may be one of the closest things we have to a working model of the raw chemical conditions that existed before life ever got started anywhere. The third major finding tends to unsettle people the most once it's properly explained. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this was happening, but for a long time, nobody knew exactly where all that escaping material actually ended up. It wasn't simply dissolving into empty space, something was catching it. Pluto's largest companion, a battered ice moon named Charon, roughly 750 miles across, orbits in an extraordinarily tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. For years, researchers suspected a link between that coloring and material escaping from Pluto, but they lacked the tools to confirm it directly. The mechanism turns out to be tied closely to Charon's extraordinarily slow, extraordinarily long seasons. Because of how Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades at a stretch in complete darkness, with no sunlight reaching it at all. That makes the pole an extremely effective cold trap, a place where escaping methane molecules drift in, freeze solid onto the surface, simply because there's no warmth available to keep them as gas, and then sit there accumulating for years before sunlight finally returns to that part of the moon. Once sunlight does return, it doesn't simply melt that frozen methane away. Instead, ultraviolet radiation and cosmic rays tear the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, essentially locking in that dark coloring permanently rather than letting it evaporate back into space. Earlier research, including a widely cited 2016 study, showed that methane escaping Pluto's atmosphere drifts across the roughly 12,000 miles of space separating the two worlds, gets captured by Charon's gravity, freezes onto its cold polar surface, and is then broken apart by sunlight and cosmic radiation into the same kind of heavy organic compounds that color Pluto's own surface. In effect, two worlds locked together in a slow, ongoing exchange of atmosphere and color that has apparently been running quietly since long before either one had a name. Charon had one more surprise in store, too. In October 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound, frozen directly onto Charon's surface. According to the published research, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. Researchers noted that this specific combination of frozen chemicals had never before been confirmed on Charon, adding yet another layer to a moon that keeps turning out to be far more chemically complex than its plain icy appearance would ever suggest. If you found this as strange and fascinating as I did while researching it, drop a comment letting me know. It genuinely helps me figure out what other space stories are worth covering next. Now, picture for a moment what it would actually be like to stand on Pluto's surface, because the details are almost hard to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare. You could stare directly at it without any discomfort. The sky around it would sit in a permanent grayish-blue gloom, thick with haze, never fully day and never fully night, just an unchanging dimness. The ground beneath your feet wouldn't behave anything like ice does on Earth. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves more like solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe, though the extreme cold would freeze exposed skin almost instantly, long before the thin air itself became the immediate danger. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each always shows exactly the same face to the other, a silent standoff running for billions of years. The surface itself holds its own separate mysteries. In a region researchers named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system. Tall rows of jagged ice blades, some reaching more than 1,500 feet high, made of frozen methane and arranged in long parallel ridges. Smaller similar formations exist here on Earth in certain high-altitude deserts, where they're known as penitentes, and rarely grow taller than an average person. Scientists believe these earthly versions form through a slow process where sunlight causes uneven melting and sublimation across an icy surface, carving out taller sections while lower areas erode away faster, gradually sculpting the ice into narrow, blade-like ridges over time. On Pluto, that same basic process appears to have played out on a vastly larger scale, over a much longer stretch of time, using frozen methane instead of frozen water. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged, frozen terrain circling the dwarf planet. Elsewhere, a massive dark region roughly the size of Alaska stretches across the equator, colored a deep reddish-black, where those falling organic tholin particles have apparently piled up thickest over billions of years on some of the oldest, most exposed terrain anywhere on the planet. South of that famous pale, heart-shaped plain, two enormous isolated peaks rise out of the surrounding landscape, and researchers still can't fully explain them. One stands roughly 13,000 feet tall, the other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes here on Earth. Both mountains have deep depressions at their summits, ringed by fractures, with lumpy, uneven flanks closely resembling cooled lava flows, except, of course, there's no molten rock on Pluto. If these features are what they appear to be, they're cryovolcanoes, structures that once erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Researchers remain divided on exactly how these particular formations came to exist, whether from a handful of massive eruptions or many smaller events spread across a longer stretch of time. But either interpretation points toward the same unsettling conclusion. Something, at some point in Pluto's relatively recent geological history, was warm enough beneath that frozen shell to force liquid material all the way up to the surface.